Hello everyone. So in this class we are going to discuss about code converters. So how to convert one types of code into another types of code. So before going to discuss this post converter, first of all I would like to tell you what do you mean by code. So different types of codes are available. So before going to this converter topic, so we would like to discuss about the different types of codes. So first of all, what do you mean by codes? So codes, it's a group of data that is we can use alphabets or special characters or it's a combinations of multiple characters. Okay. So the first thing is binary codes. So in coding, when numbers, letters or words are represented by a specific group of symbols, it is said that the number, letter or word is being encoded. Yes. The group of symbol is called as code, right? So the symbol, it may be in a number format or letter or words or some special characters. Okay, so this is called as code. Okay. So in digital, the data is represented, stored and transmitted as group of binary bits. Yes. So in digital, we are going to talk about only zeros and ones. So that's why it is called as binary codes. Because we know that in digital, zeros and ones only we are using. So basically these two are called as binary. So that's why this type of code is called as binary codes. Okay. So in this binary code only, we are going to discuss the different types of codes. So the binary code is represented by the number as well as the alphanumeric letter. Yes. So what are the advantages of binary code? See, it is suitable for the computer application. Yes, in computer we are using only this binary data, that is zeros and ones, and suitable for the digital communications. Yes, the communications belongs to digital. We are using this zeros and ones only. So this binary code is suitable for digital communications also. And the analysis and designing of digital circuits, we can use this binary codes. Since zeros and ones being used, so the implementation becomes very easy. Okay, instead of using decimal number 0 to 9, if you are using 0 and 1, so the implementation is very easy. Okay. So now the classifications of binary codes. So first one is weighted codes, the second one is non-weighted codes, and third one is binary coded decimal code, or it is called as BCD code, and alphanumeric code, then error detecting and error correcting codes. So these are all the basic codes are available in binary codes: weighted, non-weighted, by BCD, alphanumeric, error detecting and error correcting. So we'll see one by one in this lecture. So we'll see one by one regarding each and every types of codes. Okay. So first one is weighted codes. So in weighted codes, each and every bits are represented by some positional weights. So please have a look at this. So each position of the number represents a specific weight. Yes. That is, we know that the binary numbers are represented by the ascending power of 2's. That is 2 power 0, 2 power 1, 2 power 2, 2 power 3, which means this is nothing but 8421. So weighted code is called as a 8421 code. So in digital we are using this kind of format only, 8421. Okay, so have a look at this number 4. While writing this 4 in a 8421 format, so here number 4 is there. So in this place only I am going to represent the value is equal to 1. Okay, so number 2. So here 2 is there, so in this place only I am going to represent the value is equal to 1. So now this is an example for weighted code. Say for example, you guys are familiar for writing binary codes, right? So number 7, how to write number 7 in 8421 format? See, 0, 1, 1, 1. So this is the binary representation of number 7. So this 7 is now represented in 8421 format. So here this 1, 2, 4, 8 are positional weights. So each and every digits are having some weights. So that's why this code is called as weighted code. Okay. Right. Non-weighted codes. So in non-weighted codes, there is no specific codes for each and every position. So this type of code is called as non-weighted codes. So in this non-weighted codes, there are two codes we are going to use. This is XS3 code and gray code. Okay, we'll see one by one. XS3 code and gray code. So the first one is XS3 code. So how to calculate this XS3 code means, let's add number 3 to each and every digits of the given decimal number. Okay, have a look at this. This is decimal number, 0 to 9 is represented, and this is 8421 normal format, 8421 format. So now if you want to calculate this XS3 code for this decimal value means, let's add plus 3 here and here plus 3 plus 3 plus 3 up to number 9 we can add plus 3. So 0 plus 3 it is 3, 1 plus 3 it is 4. So have a look at this. This is number 3 and this is number 4. 2 plus 3 5. So this is number 5 in binary representation. Okay. Otherwise this is a decimal to XS3. So suppose you want to go convert this BCD to XS3 means, then we need to add the binary value 3 to each binary number. Okay, so that is 1 1 0 0. So this is equal to 0 and this is equal to 3 and the result is 3. That is 0 plus 3 which is equal to 3. See, in decimal we have added 0 plus 3 and we got 3. And similarly for BCD number we need to add it is 0 0 1 1 to the given BCD number. Okay, so this is the way to convert one normal decimal value into XS3 code. See, first decimal number, then first write it into the 8421 BCD format, then add 0011, then you will get XS3. This is one type of non-weighted codes. And the second thing is gray code. So what do you mean by gray code? So gray code is nothing but this is a otherwise called it is in a one-bit change code. One-bit change code, otherwise it is cyclic code. What does it mean, one-bit change? That is, while going from ascending order, that is, see, while going from 0 to 9 in ascending order, that is 0, 1, 2, 3, 4, 5, have a look at this gray code. So the number of bit changes is only one bit change. See, first 4 0 is there. Have a look at the difference between first number and second number. So here only one bit change. Now compare 2 and 3, here only one bit change. Now compare 3 and 4, here only one bit change. 4 and 5, one bit change. 5 and 6, one bit change. So while moving from ascending order, the number of bit changes is only one bit change. So there will be a separate procedure will be there to convert a BCD to gray. Like BCD to XS3 we have added number 3, that is 0011. So in this similar manner, there is a separate procedure will be there that we will discuss in the next class while going for a converter topic. Okay, so now this is what a gray code. So it is otherwise called as one bit change code, otherwise cyclic code. Okay, because while moving from one number to another number in proper ascending order, okay, 0, 1, 2, 3 to 9, the number of bit changes is only one bit change. That's why it is called as unit distance code or one bit change code or cyclic code. Okay, right. But we cannot be able to use this gray code and XS3 code for normal arithmetic operations. See, this is one biggest disadvantage of this gray code. Cannot be used for arithmetic operations. Okay, right. Then binary coded decimal, that is a BCD. This is also looks like a normal 8421 code. While we are representing the number from 0 to 9. Once the number is crossed number 9, that is, suppose if you are going to write 10 in BCD format, then you need to write separate 8421 for this first bit and as well as this second bit. Let us see. Number 0 in 8-bit for 8421 format is it is 40. Number 1 is 0001. Similarly, number 7 is 0111. And number 9 is 1001. If suppose number 10 I am going to write using this BCD format, then I need to write number 1 separately, that is 0014 bit format, and for number 0 separately 0000. Okay, similarly if I am writing number 15, So number 1 is separately we need to write, and number 5 0 1 0 1. Okay, so this is what BCD code. So up to number 9, which is similar to 8421, that is a normal weighted code format. But after number 9, we need to add like this. Okay, in normal BCD addition, what we are going to do means, if the number is, that is the result is greater than 9, then we are going to add number 6. That part will go for while BCD addition. Okay, so now this is what BC. So up to number 9, which is equal to normal weighted codes. Then after number 9, we need to write separate 4 bit for each digit. Okay, right. And alphanumeric code. A binary digit or bit can represent only 2 symbols. Yes, as of now we have discussed only zeros and ones, only 2 values. But this is not enough for communication between 2 computers. Yes, if you are communicating from one computer to another computer, these 2 values are not enough. Okay, so then we need to use some extra characters and symbols. Okay, see, these symbols are required to represent 26 alphabets with the capital and small letters, numbers from 0 to 9, punctuation marks and other symbols. Okay, so only zeros and ones, it's not enough. So we need to use more number of alphabets. Okay, so in alphanumeric codes, there are 2 types will be there. One is American Standard Code for Information Interchange, that is ASCII code. Another one is EBCDIC code, that is Extended Binary Coded Decimal Interchange code. So which is nothing but, in our computer keyboard, we are having variety of symbols, that is we are having alphabets A to Z. We can use small letters as well as caps letters and C. These are all some special characters which are available in our keyboard. So when you are giving this data as an input to your computer, the computer will convert these symbols into this alphanumeric format. Okay, the computer, it won't accept this colon and semicolon question mark directly. So whatever you are giving, first it will convert into proper alphanumeric format, then only it will do that operation, particular operation. Okay, right. So ASCII code and EBCDIC code is the 2 types of these alphanumeric codes. Next, error codes. So what do you mean by error? First, what do you mean by error? When we are communicating from one side to another side, suppose extra signals will be added along with your original message, so that extra signal is called as error. That is, normally in communications, the main problem will arise using a noises one. Okay, so let's see. So error means because output information does not match with the input information. Okay, so some extra signals added along with our original message, that is what error. So in this we are going to discuss 2 things. One is error detecting code, another one is error correcting codes. Okay, so error detecting and correcting. So first time we are going to detect the error, and second time we are going to correct the error. Right? See, this is computer number 1, computer number 2. We are sending our original signal, binary signal, but at the computer number 2, we are receiving original data with noise. So this noise is called as error. Now we are going to identify this noise and we are going to eliminate this noise using these 2 types of codes, error detecting and error correcting codes. Okay, right. So see, error detecting code, whenever message is transmitted, it may get scrambled by noise or data may get interrupted. Okay, may get corrupted. So how to detect these codes? We are going to use one extra data. That data was called as parity check. With the help of this parity check only, we are going to detect the error as well as we are going to correct the error. Okay, so see, in error correcting codes, this error detecting codes, it will detect the error alone, but in error correcting code, it is going to detect the error first as well as it is going to correct the error. That is, once you have identified the location, that is, see, 1011, this is our expected result. If suppose I am going to get 1010 means, so here is the error. So this value will be reverted. That is, 0 will be reverted by 1 and 1 will be reverted by 0. So 1011. Okay. So for this correcting codes also, we are going to use parity bridge. Okay, right. So we'll see this how to detect and correct the errors in the next section. Okay.